In one of the deepest images the James Webb Space Telescope has ever taken, there is a single red point of light. And at first glance, it looks like nothing special. It's not a spiral galaxy, it's not a nebula, it doesn't even really look like much of anything. It's just a tiny, unresolved red dot sitting in a field of thousands of other galaxies. But when astronomers actually pointed a spectrograph at this thing and broke its light apart into a spectrum, they found something that, and I mean this in the most literal sense possible, should not exist. The object is roughly the size of our entire solar system, and it is pumping out something like 100 billion times more energy than any normal star could ever physically produce. Not more energy than our sun, more energy than any star, full stop, anywhere, under any known process of nuclear fusion. And so the team behind this discovery, led by Rohan P. Naidu, who's affiliated with MIT and the University of Hawaii, along with Jorit Mathi at the Institute of Science and Technology Austria, came to a conclusion that sounds like it belongs in a science fiction script rather than a peer-reviewed paper. They think this object is a black hole, wrapped in gas so dense that the entire structure glows like a star. They're calling it, and I promise I'm not making this up, a black hole star. But before we get into what that actually means, I guess we should take a step back, because to understand why a black hole star is such a strange idea, you kind of need a quick refresher on what makes a star in the first place, and why that's supposed to be completely different from a black hole. A star, at its core, is basically just a massive ball of gas that's being held up against its own gravity by nuclear fusion happening in its center. Hydrogen atoms are getting smashed together into helium. That process releases energy, and that outward pressure from all that released energy is what stops the star from collapsing in on itself. That's the engine. A black hole is sort of the opposite story. It's what's left over when there's no more fusion happening, when gravity has completely won and matter has been crushed down into something so dense that not even light can escape it. Black holes don't glow on their own. If we ever see one shining brightly, it's usually because of something called an accretion disk, which is just a flat, swirling ring of superheated gas spiraling into the black hole before it crosses the point of no return. Think of it kind of like water circling a drain, except the water is glowing white hot from friction as it spirals inward. So under the normal picture, stars and black holes are basically opposite ends of stellar evolution. One is the engine of creation and the other is the leftover wreckage. What Naidu and his team are now proposing is a kind of hybrid that nobody had really taken seriously before. A young, rapidly growing black hole that isn't surrounded by a thin, flat accretion disk, but is instead completely enshrouded, almost cocooned, in an enormous, puffy envelope of hydrogen gas. And because that envelope is so thick and so extended, roughly the size of our entire solar system, it doesn't behave like a normal accretion disk at all. Instead, it acts kind of like a pseudo-photosphere, which is basically the fancy term for the visible surface of a star. In other words, the black hole is doing the job that nuclear fusion normally does. It's the power source, and the dense gas around it is doing the job that a star's outer layers normally do. It's what actually radiates the light we see. Essentially, from the outside, the whole system looks and behaves an awful lot like a gigantic star, even though there's no fusion happening anywhere inside it. And this actually connects to a mystery that astronomers have been sitting with since almost the very first images JWST ever released. Starting back in 2022, deep field images from Webb turned up a strange, unexpected population of objects that are small, extremely red, and just kind of everywhere in the early universe. Astronomers started calling them little red dots, and as of now, something like 300 of them have been catalogued. They mostly show up in a specific window of cosmic history, somewhere between about 600 million and 1.6 billion years after the Big Bang, and then, weirdly, they basically stop appearing. By the time you get to the present-day universe, little red dots have essentially vanished as a population. Nobody has been entirely sure what they actually are, and honestly, it's been one of the most argued about topics of the entire JWST era. Which brings us to the actual study published in Nature on August 12th, 2026, under the very dry title, A Gas-Enshrouded and Gas-Reddened Black Hole at Cosmic Dawn. The object at the center of it is named MOM-BH Star 1, and the name comes from the survey that found it, a JWST program called Mirage or Miracle, or MOEM for short. And I love that name because it basically tells you what the whole survey is designed to do. It deliberately goes hunting for objects that are risky, meaning they could either turn out to be genuinely spectacular discoveries, or they could turn out to be boring interlopers, like a cold, nearby star that just happens to look like it's sitting way out at the edge of the observable universe. MOM-BH Star 1 turned out to be very much the former. Based on the spectrum, the team estimates that the central black hole weighs in at around 100,000 times the mass of our Sun, which, for context, puts it somewhere between the stellar mass black holes that form when individual stars collapse and the truly monstrous supermassive black holes, which can be millions or even billions of solar masses that sit at the centers of large galaxies like our own Milky Way. That 100,000 solar mass core is then wrapped inside a dense, extended cocoon of hydrogen gas that's roughly comparable in size to our own solar system. And that gas is what's absorbing the black hole's light and re-emitting it in a way that mimics a star's spectrum, while also giving the whole object its distinctive deep red color. What makes this particular object so useful, scientifically, is something Naidu has pointed out directly, which is that MOM-BH Star 1 seems to be almost completely on its own, not buried inside a big, bright host galaxy the way most little red dots appear to be. Because of that, its light isn't getting mixed together with starlight from a surrounding galaxy, so what astronomers are looking at is more or less pure, unpolluted black hole starlight. And when the team took that clean spectrum and mathematically added it on top of the light from an ordinary young galaxy, the combined result reproduced the spectral signature of a typical little red dot, almost exactly. In other words, this one clean example may have let them isolate the actual engine that's been hiding inside the little red dot population the entire time. Okay, so at this point you might be thinking, great, mystery solved. Little red dots are black hole stars. Roll credits. But I guess the more honest question is, why should we believe this particular explanation over any of the others that have been floating around for the last few years? And that's actually a fair thing to ask because the little red dot debate has had several competing camps for a while now, and none of them have folded easily. The first major camp said little red dots might just be dusty, massive starburst galaxies, meaning ordinary galaxies packed with an enormous number of young stars, whose light is getting reddened as it passes through thick clouds of dust on its way to us. The problem with that idea is basically one of bookkeeping. To explain how bright and how red these objects are using dust and starlight alone, you'd need an almost implausible amount of stellar mass crammed into an incredibly compact space. And some researchers have flagged this as something close to a dust budget crisis, where the numbers just don't comfortably add up. The second camp said little red dots are heavily obscured active galactic nuclei, or AGN, which is basically the standard picture of a supermassive black hole actively feeding through a dusty accretion disk. This explanation has some real strengths. Little red dots do show the broad emission lines you'd expect from gas whipping around close to a black hole at incredible speeds, but it also runs into trouble, because typical dust-reddened AGN are expected to give off strong X-ray emission, and deep X-ray searches of little red dots have mostly come up empty. AGN are also expected to flicker and vary in brightness over time as their accretion disks fluctuate, and most little red dots studied so far have looked suspiciously steady. And then, and this is my personal favourite because of how recent it is, there's a third, genuinely competing idea that came out just about a week before the Naidu paper. On August 5th, 2026, a team associated with the Harvard-Smithsonian Center for Astrophysics, led by researcher Nandol, published work arguing that little red dots might actually be pulsating, Supermassive stars, ordinary stars, just absolutely enormous ones, roughly 100,000 times the mass of our sun, that are unstable and physically pulsing in a way that can reproduce the same V shaped spectrum, the same compact appearance, and the same broad emission line signature that little red dots show. According to a review published around the same time by researchers Vida and Faber, that's actually the first model that's managed to explain all three of those defining features simultaneously rather than just one or two of them while stumbling on the rest. So, where does that leave us? Honestly, kind of in a really interesting spot because we've now got at least four serious contenders: dusty starburst galaxies, obscured AGN, pulsating supermassive stars, and now black hole stars. And every single one of them can explain part of the puzzle while still leaving something unexplained. The black hole star model has a real edge here, mainly because it doesn't force you to invent enormous amounts of hidden stellar mass, and it doesn't require the X-ray emission that obscured AGN really should be producing, but generally aren't. Naidu and his collaborators have since gone back and checked roughly 100 other little red dots against this new model, and they report finding what looks like a similar gas-enshrouded core sitting at the heart of essentially every one of them, which is a genuinely striking result, but it's also worth being honest that consistent with is not the same thing as proven. And other researchers in the field, including astronomer Christian Wolff at the Australian National University, have described this less as a final answer and more as a first real glimpse at something like a supermassive black hole, teenager, an awkward in-between growth stage nobody had actually caught in the act before. And that's really the heart of why this matters so much, beyond just naming a weird red dot. One of the biggest open problems in all of astrophysics right now is explaining how supermassive black holes, the kind that weigh millions or billions of times the mass of the sun, manage to grow so enormous so quickly, some of them appearing to already exist within less than 1 billion years of the Big Bang. Under the normal slow route, where a black hole grows a little at a time, by feeding gradually through a thin accretion disk, there simply hasn't been enough cosmic time for that math to work. Black hole stars, if this interpretation holds up, might represent exactly the missing evolutionary link. A chaotic, extremely rapid growth phase where a young black hole isn't politely sipping gas through a disk, it's basically drowning in it, wrapped in so much surrounding material that it can feed at a rate far beyond what the normal rules would otherwise allow. Which means that somewhere out there, buried in hundreds of these little red dots scattered across the deepest images Webb has ever taken, we might actually be looking directly at the awkward, gas-choked adolescence of the very same kind of black hole that now sits quietly at the center of our own galaxy. And if that's really what's going on, the next question almost writes itself, because if black holes really can grow this fast, this early, then how many more of these things are still hiding in plain sight, waiting for someone to finally point the right instrument at exactly the right red dot?